According to the Pascal's law, a change in pressure exerted at any part of a liquid at rest is transmitted equally and undiminished in all directions throughout the liquid. The change in pressure gets transmitted throughout the liquid and is independent of the direction and size of the container. Hydraulic lift and hydraulic brakes are two common applications of Pascal's law. Let us understand the working of a hydraulic lift. In a hydraulic lift, two cylinders of different area of cross-section are connected through a tube. Each cylinder is fitted with an airtight piston. An incompressible liquid is filled in the cylinders and the connecting tube. Now, a force is applied at the piston of the smaller cylinder. This force exerts a pressure at the piston. The pressure so created gets transmitted throughout the liquid and hence exerts a much greater force on the piston of larger area of cross. In this way, the piston gets pushed in upward direction with a greater force, and a weight kept on this larger piston also gets lifted in upward direction. Let us now see how a hydraulic brake system works. The master cylinder of the system is connected to the wheels of the vehicle. When we apply a small force on the brake pedal, the piston of the master cylinder moves inward and creates a pressure in the fluid. This pressure gets transmitted throughout the liquid. This produces a large force on the brake shoes. In this way, a small force on the brake pedal produces a large force on the wheels and hence retards the vehicles.